I think I've started the recording, so it's fine. Yeah. Okay. Fine. Okay. 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 Fine. So, oh, my screen is not visible, right? Yeah. Let's see. Okay. Okay. Fine. So, the first thing that we do today is sorry, is to think is to discuss this question one. So, what if the pivot is in the median? Okay. So, I hope you all remember the quicksort algorithm, right? So, just let's have a quick question one of lecture 04. Okay. So let's just have a quick look at. All right. So let's just have a quick look at the quicksort algorithm. I hope you remember it's a divide and conquer algorithm, right? So we we choose a pivot and we divide the problem into two parts, and then we solve them recursively, right? And after that we find the solution. Like this is a sorting problem. So I would suggest you guys, if you have your lecture note 4 with you, please open it. We'll discuss the last two questions of the lecture note. Okay. Now, so I'm starting with the first question. So if you look at the first question, it says that what if we choose the pivot to be the median? Okay. So median means it. So if we choose the pivot in quicksort to be the median, then the whole array is divided into two parts, right? In equal parts. So there will be the array is partitioned into equal parts, or like 1:1 ratio. Okay. So now is this familiar? Somewhat familiar to you guys? Yes, yes, this one. Yeah, this one. This is the lecture note I'm talking about. So is this familiar to you? Like the 1:1 partition? Have you seen it before? So you have seen the same thing in merge sort. So this 1:1 partition case is same as merge sort, right? Because in merge sort, if you remember, we try to break it in the middle and break it into two parts, right? Since we are breaking in the middle, the size of these two parts are almost equal. So if you recall that your partition is like somewhat like this following this recurrence relation. Okay. Do you agree with that? So is it okay? This is the recurrence of March sort, right? Since you are dividing in 1:1, so you have this array and you choose the median elements, let's say this, then half of the element should be on this side because median is the, like, if it is sorted, then median should be in the middle. So it has exactly half, not exactly, almost half of the values should be on its left and half of them should be on its right. The right values are greater than the median and lower values would be on the left side. So this, if this is your median, then these partitions this whole array of numbers into two equal parts, right? This x and y. This x and y are almost equal because this, let's say r or m is your median. Okay. So if m is median, then it's dividing it into two equal parts, almost equal parts. So the situation is similar to the March sort. Okay. Clear? Okay. So this recurrence relation, the same recurrence relation as March sort will be applied on this case. In this case. Okay. So what is the running time for March sort? Yeah. So what is the running time for merge sort? It's order n log n, right? So if you, yes, order n log n. So if you solve this recurrence, you will get order n log n. Okay, fine. So this is the answer of the question 1. Okay. So now let's move on to question number 2. So in question number 2, it asks that what if we choose a pivot to be the minimum or maximum element? Okay. So if this is your array, and this is your array of numbers, and let's say you choose the minimum element. Okay. So that means what? All the rest of the elements of that array, of this array, should be on the right of this element, right? So if this is your pivot element P to be the minimum element of A, so uh, all other numbers in this array should be on the right of P in quicksort, right? So how, what should be the partition? So in the partition, you have Tn, the you have one part. So the quicksort will partition it into this part, like this is your P and this is the rest of the numbers, n minus P, the rest of the numbers in the array. So it's almost a division like like n minus 1 numbers are here and here is 1, right? So the division would look like something like T1 plus Tn minus 1 plus order n. Okay. So this is the recurrence relation corresponding to the second case, right? Okay, clear? So we can write it in this way that Tn minus 1 plus Cn. Okay. Now if we break it, I think if you solve it, so what is the answer? I think some of you can answer this one. What should be the running time if you solve this recurrence relation? Okay. So let's say if you break it in another step, so this would be Cn minus 2 plus Cn plus Cn minus 1 plus Cn. Okay. Sorry, write it clearly. Cn minus 1 plus Cn. Okay. So again, if you break, it would be Tn minus 3 Cn minus 2 plus n minus Cn minus 1 plus C. And it will continue, right? Order n square, yes. So it would be something like in the end you will get C2 Cn minus 1 plus dot up to C1, which is nothing but C of n plus n minus 1 up to 1. You know that this series has some like what is the sum of this series 1 to n numbers? What is the sum of n numbers? N into n plus 1 by 2, right? So it's something like we can say this is something like order n squared term. Yes. So we can write it as order n squared. Right? So in this case, the same thing will happen if you choose the minimum element, so the maximum element. So the running time would be order n squared in this case. Okay. So this is the worst case for quicksort. That you choose the pivot to be the minimum or maximum element. Okay. Right. Now let's face another question, like what if, so this third question is, what if we choose a pivot that partitions A in 1:3 ratio. Okay. So can someone tell me like what would be the recurrence relation for corresponding to this one? If you observe the previous two cases, you can find the recurrence relation corresponding to this one. So what should be that? So the question, I think question is clear that in quicksort, if you remember, in quicksort, we first pick up a pivot and we divide the array based on that pivot. We actually practically find the elements which are smaller than this and which are bigger than that one, bigger than the pivot, and we uh, run the recurrence relation corresponding to those two parts. Okay, so we divide the whole array into two parts based on that pivot. So here, if we choose a pivot to be some element like it's causing like uh, the array to be partitioned into 1:3. So what would be the recurrence relation? Like how can we, or what is the recurrence relation corresponding to this partition? So you have your array A. This is the question, that you have an array and you choose a pivot, let's say P, such that this part is 1/3 of A and this part is 2/3 of A, right? This is the meaning of 1:3 partition. Okay, right? So after that, now you have to now what quicksort do is that quicksort will recursively run on this part as well as this part, right? So if you want to compute the running time of this in this case, so then your total running time should be this one n by 3 part. So if you have n elements, it will part into n by 3 and 2n by 3. So if you have n elements, so if the size of A is n, then it should be partitioned into n by 3 and 2n by 3. So 2n by 3 plus order n, which you can write it as like Tn by 3 plus T2n by 3 plus Cn. Okay. So from here, can you guess the running time? Okay, first of all, also there is one question like, do you know any methods to solve this kind of recurrence relations? Like there are 3 methods to solve the recurrence relations uh, of such recurrence relations basically. So do you know any methods? So there are practically 3 methods. Oh, okay. Okay, fine. You can look up to the methods, other methods. I mean, okay. Okay. The first method is recurrence tree. Second one is substitution. And third is master method. Okay. So there are 3 methods to solve these recurrence relations. But for this simple recurrence relation, you need just the recurrence tree method, or you can use the recursion tree. So what you need to observe is that if you have this part, if you go further into the next iteration, then what do you have? You have something like n by 3 square plus n 2n by 3 square plus t 2n by 3 square plus t 2 square by 3 square n plus cn plus c. Is it okay? So if you go into the next step, you have your n in here. You have n elements in here. Then you break it into 2 parts, n by 3, 2n by 3. Okay. Now you are making it further, n by 3 square, 2n by 3 square, right? That's our recurrence relation suggesting that we are breaking it into 2 parts. So 2n by 3 square, 2 square by 3 square, right? So breaking it like that. In the last second step, this step, are you talking about this Tn by 3 plus 2 T2n by 3 plus? Okay, so this is nothing that you have order n term. So order n can be written as some constant multiplication of n. So c is a constant in here. Okay, some arbitrary constant. Okay, so since it's an order n term, you can think of it in this way. So it's just I have not got the first question answer. Okay, what's your problem in the first question? Oh, okay. Okay, fine. Okay, I'll visit. Okay. Next. So up to now, is this fine? That we break it into the next step. So now, after this, if we break it further, then you can see that one term. Okay, let me simplify this one. So if you have simplify this one, it would be like t 2 into t 2n by 3 square plus t 2 by 3 whole square n plus cn. Okay, so this is what you got. This is the term you got after simplification, right? Now you can see that this term, that 1 by 3 square, this, if you follow this road, this n by 3 square, next term would be n by 3 cube, right? It will go in this way, and this term will go like 2 by 3 whole cube, and so on and so forth. Okay, this will go like that. So it's easy to see that this, so that means what? This term is decreasing, the value is decreasing rapidly than this term, okay. So since it's decreasing with the factor like 1 by 3 to the power k, this is decreasing with 2/3. Okay. Okay. So the so if you if you remember that what we do is that we keep on doing the same thing until we get this values of t inside this to be 1, right? So the last term would be something like 2 by 3 to the power k n plus cn, plus cn up to this should be k times actually. Okay, I should write it in this way. Plus cn plus cn. This will take k times. Okay. So with the same way, this should be 1 after which the recurrence is stopped. And if this is 1, then your n is, then your k is nothing but log 3 by 2 n. So your number of iterations is, you can count the number of c cn in here, there are k times. So you have n cn into log n 3 by 2, which is nothing but order n log n again. Okay. So is it clear, or is there any question? Okay. So okay, fine. So what we are doing is that we started with this recurrence relation, and after first step we break it. After first step, this is the first step. After first step, we break it into furthermore. So this is the first step. Next we went to the next step. So from next step, it's evident that this this side, if you follow this side, this is decreasing with the factor of 1/3, right? Because see, decreasing means the it's like, what is 10? Oh, it's just one extra bracket. I mean, I just wanted to mean. Okay, let me 2/3 to the power k n. Let me just clarify. So if you follow this side, this is decreasing with multiplication of 1/3, and this side is decreasing by by the multiplication of 2/3, right? Now, which one is going to be longer? Because you want to find the height of this one. Okay, you need to know that how many steps you need to break to reach to the 1-1-1 stage, right? You cannot carry the algorithm when there is single element. Okay, so to reach the single element, which one should reach the fast? faster. Which subtree should be the faster and which subtree should take the long time? It should be this part, right? Which takes the longer time because it's decreasing slowly. Okay. So if you go, since your algorithm will continue till it find the element, single element, as long as this is not equal to 1, it will continue, right? It will continue to find the steps. So in here, we have find that, let's say after kth step, it finds that 2 by 3 whole to the power k n is equal to 1. Okay, so that's what we have said. This is equal to 1. So from here we can derive that it's k equal to log n. So which in turns will give you the it's n log n. Okay. So any question, like is there any? Is it clear or? It's not. Understood. Okay. Fine. Okay. Fine. So first answer is, if you go to the first problem, it's said that you partition into median. So median will partition the whole array into two equal parts. Okay. So almost equal parts. So almost equal parts means it's kind of 1:1 partition. So you have already seen that in the merge sort, we have this 1:1 partition, because in the merge sort we choose the middle element and we break the array into two parts and then we solve it. So the recurrence relation is same as merge sort. Should be this one, Tn equal to 2Tn by 2, 2Tn by 2 because there are two almost equal parts. So 2Tn by 2 plus order n. Now you have already I think you have already done that. This running time of this algorithm is order n log n. This recurrence relation is order n log n. So in this case, it will be order n log n again. Okay. Okay. Anything else? Question number 2 or the third one. So question number 2 is relatively easy. It's just you select the minimum or maximum element. If you choose minimum or maximum, whatever you choose, this is corresponding to the minimum. The same thing will happen corresponding to the maximum. So it's partition the whole array into like 1 n minus 1 partition. So if you follow the recurrence relation, it will be like Tn minus 1 plus order n. T1 is again a constant time, so it will be Tn minus 1 plus Cn. So if you break it further, it will look like some series of series sum of n numbers, and that is nothing but order n square. Okay. Okay. So The 2/3, I mean the 1:3 is also fine, I guess. So if this is clear, then I will move on to the next part. Last question. What is first question? I mean the last question. Are you talking about the last question? That 1:3 partition. Okay, see. You can take any factor, okay? For example, like you can choose 1:5, 1:6, or even 2:3. Anything you choose. It's basically any if you choose A by B type thing, A is to B, not A is to B. Okay, let me just. So for example, if you take 9:10, okay. 9:10 or 1:9, let's say 1:9. It would be very bad factor. 1:10 factor would be good. 1:10. Okay. So first you have the whole elements, whole n elements. For that you are spending order n time. Okay, this is the time that you are spending. Next you divide it into, so n by 10 part. This is 9n by 10 part, right? You divide it into 2 parts. Okay, that will, the total time you spend in this case is 3 cn. Again the cost is same, right? Next you spent n by 10 square, 9n by 10 square time in this part. Okay, and what do you do in here? 9n by 10 square and 9 by 10 whole square n time in this node. The total time again spent by you is cn. Okay, and then you continue in this way. If you up until which point you will continue? When this is a constant, like one element, you cannot break it. Same thing will happen. There is only one. There is only one, and only one left. Okay. You cannot break it further. The size is one. Now, if you reach at this stage, so think about which one should be the longest among this. Like you can see that you are following some path here, no? If you look, come here, then you come here, then you come here. Okay, or you can come here and then you can come here and you can come down in this part. So you are following some path from this part. Okay, from this top. So your and each step you are computing some cn, and this last step you also compute some cn. So you have to count that what is the longest path in this case from here to the down. Okay, now to understand that, you just need to check which one is going slower, which one is decreasing slowly, which one is decreasing faster. This one is decreasing with the rate of 1/10. Okay, this one is decreasing with the rate of 9/10. This one you multiply with factor 9 by 10. which is actually smaller than this factor 1 by 10. Okay. So when you which is actually greater, which is actually greater than this 1 by 10. So this 1 by 10 will decrease rapidly, and this 9 by 10 will decrease slowly. So the longest height will be on this path, up to which you reach at the bottom. So you have to check that, let's say if you are following k number of iterations, there are total k times. So when this should be equal to 1. Okay. So then you will find again some log 10 by 9. And k equal to some 10 by 9, log 10 by 9, and which is nothing but let me properly, log 10 by 9n, which is nothing but again order n log n, because you have cn operations, cn k times, so that's cn log cn log 9 by 10, 10 by 9, which is cn log n. Okay. So you have to understand like which one is decreasing slowly and which one is decreasing faster. Since 9 point, it's decreasing like 0.9. So 0.9 has higher value than 0.1. So it will like continue longer. This will decrease faster, n by 10. Okay. Is it clear? Okay, fine. Okay. So, okay. So next, what we do is today's coding class, we will do the coding for merge sort algorithm. And first, I need to discuss some basics that we need for merge sort. I think most of you has problems with C. So I'll discuss some basics of C programming that will help you to understand the codes in the merge sort. So how many of you, first of all, I need to know like how many of you have done coding in, no, not coding. I mean, how many of you are familiar with a function? Functions in Python or functions in any C++ if you are working, some of you have worked in C++. Okay. So yes, functions in Python. Yes. So there are some like inbuilt functions and there are some functions that you define. Okay. So all basics. Okay, you have covered all the basics. That's good. So okay. So the functions, there are some like two kind of functions. One is inbuilt functions that you can directly use by command, and one is the function that you define in your code. Okay. So for example, like in the last coding class, if you remember, we have used one inbuilt function called this main function. The integer main or void main, whatever we have used, is the main is a function actually, and it's already there. It's already defined. Okay, you don't have to define it, but in today's in like when we deal with merge sort, if you remember, merge sort runs on recursion. Now recursion can be handled without using functions, but it's easy to write the code using the functions. So we will use we'll use functions for merge sort. Okay, fine. That's good. You know C. So I'll just discuss something about these functions, and I think I have already discussed about the data types in the last class. Okay. So if you remember that we have to declare the variables first. So okay, so we have seen that you have to declare the variables first, and there are like a few variables that we have discussed for integer. There are some mostly we are dealing with these integer types, and for integer types there are like, to read that function we sorry uh, now we first what we need to do is to after you give an input as an integer, or you define some integer, let's say integer a or b. This is the way to define the integer by specifying the type of the variable and the name of the variables. And after that we use the functions scanf and printf. Scanf to read the function, to read the given input, and we use the %d to read the input stored at location a or and b, and we need, sorry, we need to, so one more thing. Okay, yes, this is important. When we are, let's say you define two functions, instead of scanning like one by one, you can directly scan using the 2%d. You just have to mention the address of the corresponding variables separated by a comma. This should be, there should be a comma between them. Okay, so this is how you can directly input two integers. Okay. Yes, scanf to take the, so yeah, yes. See, scanf is what you have given. So if you already define something, let's say if you are using integer a and you directly give the value in here, let's say you write a equal to, let's say you write integer a b equal to 1, then you fix, you already assign, already given the value of 1 to b. Okay, so you don't need to scan it again. Scanf is basically whenever you give an input to this variables, then it checks whether this is correct or not. Okay, this reads the input. There are long integers, yes, there are long integers, long integers, uh, but we are not dealing with this type of things right now. So I'm skipping that one. I'm just focused on the code. I think it's important to understand the code as well as the algorithm also. So for now, let's settle on these integer values. Maybe float, we'll see some float, but mostly some character variables and strings. Okay. So first, so mostly about scanf and printf I have discussed in the previous class, and I think it is almost clear about this function, about the use of these functions scanf and printf. Printf is a interface. Whatever you want, you will see. You should. It's in the. It's in the that will appear in the whatever you whenever you run the code, whatever the one who is running the code, you will see that whatever comes, that will be the printf. Okay, printf will be okay. Yes. It's for user. Just remember the context of this. Okay, I'll try to write. My handwriting is actually bad. Uh, this is integer, and writing in this is actually a big problem. So printf is just remember the syntax. Like you have to use inverted comma, whatever you are writing, and end it with a semicolon. That's it. Okay. Printf is yeah, it's the same thing. Okay. Uh, so the and other things like if loop, there are some loops actually. One also very important things are loops in C. So you'll see some for loop, if loop, while loops. I think you know these loops. You have used these loops in some other language. Okay. Percent D for integer, percent F for float. Yes. Percent C for character. Yes. Those will be done later. Percent F for a do while. Yes. Yes. Do while is also there, but do while and while is almost same. So if it's not loop in Python. Okay. So we'll mostly use for and if. Now we also use while. These three are the most used loops that will come face to face with. I don't have much time to discuss all the basics of C programming, so I'm just focusing on the things that we need for this for our coding purposes. So for loops has three components, if you remember from the last class. One is the initialization, from which you are starting your for loop. It's the initial. This will define the final, that's up to which you want to run your for loop, and this is the increment or decrement. Okay, whatever you want to do with the for loop. So for loop has this basic structure. Okay, and everything is written inside this, so it will continue iterate based on your instructions. And if loop is basically whatever condition you will write in here, it will execute on that. So if generally follows with an else. Okay, and maybe sometimes you have to use like else if condition also. Okay, so there is else if, that's a nested if loop. Else if you have given another condition, then else, and so on and so forth. So this is how this if loop, else if, and else goes in C. Yes. Where can we write C code without installation? C. Uh, you can do it in online GDB. In the last class, you have seen that I was writing a code in an online portal. You don't need to install C in your system. It's an online portal. You can write the code in there. You can check, and you can copy the code into some text file or something. Okay, so you can do that in your system without installing C. You don't need to install C. Uh, all right. So what was it? If loop, and while loop also runs on a condition. So you given a condition in the while loop. Yes, this one. Even I will write the code in this format. Okay. Now the main thing that while also has the same structure, so I'm not describing that. So the functions. Okay. So let's say let me take an example. So if you remember previously, let's say I write a code computing an area of a circle, let's say. So this is the problem that we will deal with. Okay, we will write a code corresponding to this form. So area of a circle. Okay, this is the problem that we will deal with. Okay, so as you have seen, we already discussed the use of this stdio.h. This is the standard input output header file. It will uh, it will contain all these functions, this printf, scanf, and main and all. So okay. Now let's say we define another a function. So this is, let's say, area computation. I am using integer values. So in function, you have to mention the type of the function. Okay. So uh, this is the type that will return by the function. Okay. So integer type means it will return an integer value. Uh, float means it will return some float. Okay. So you should be clear about what is the type of that function. Okay. What is the type of value that will be returned by the function? If you remember, in the last class we have used like integer main. There is another void main. Yeah, void is also there. Void is also there. तरह से बार-बार ना लिखना पड़े. Any solution? No, main is you have to write main because your code will be executed in the main function. Okay, so but yes, without using integer, you can define the void main. Sometimes you can simply use the main, but you have to use a main function. Without using main function, your code will not be any shortcut of without main. No, there is no shortcut in C without main. Void is again you are using you see, not only void, you have to use the void main. If you don't use main, your when you are executing some command or whatever you want to do, you let's say you define some functions, but all your input output and everything that would be dealt with this main function. So you have to write everything inside the main function. The other functions that you defined, you can define it outside. Even it should be void main. Okay. So let me write this one, just an example of a function. So integer, some function, and here you declare the type of variable, or this is called actually argument of that function. Type of variable and name of variable. Okay. So for example, integer and arg. So this is called argument. So this is function argument. Okay. So this is how we define a function, and then we start. So let's say integer. If you want to compute the area, you know that it's pi. Okay, pi is not defined, right? So let's say you use 3 to r into r, and like return a. And when you use the main function, what you do when you call this function, you have to call this function. Okay, so you can directly call it. Like let's say integer, uh, you have to define r and a, the area, and you have to define the function also, function that integer r, and you scan the value percent %d, that, and a equal to uh, function integer r, and printf that area is. Okay, so here you declare the function, declare the function, and here you call the function. Okay, so you need to follow these steps while using background noise. Oh, pointer. Okay, I'll come to that. For today's code, we don't need pointer. It's simply done, can be done with the use of. Is it okay now? Okay, okay. What is a pointer? Okay, I'll discuss about pointer, but we don't need pointer today, so I'm not thinking about discussing it. Yes, the code. See, in this code, actually, I was trying to write what is like how what is the way to represent a function in how to write a function, actually, how to write a function in C. So for that, you need to first define the type of the value that returned by the function. It can be integer, it can be float, it can be void also. That void means that it's not returning any particular value, and also it has some name, the name of the function, and has as an argument. And in the argument, you define the type of the variables. You also define the variables and its types. Okay. Then you come to the main body of the function. Here you will do whatever you want to do. For this purpose, we are discussing the problem finding area of a circle. So we just simply define a variable, another variable, and we multiply like pi r square. I'm taking pi equal to 3. So this function will return, if you call this function and you give the value r, give the value of r in the argument, then it will return an area of circle. Okay. So after defining this function, you have to declare this function in the main, and you have to call that function. So that is done in these two steps. Okay, we declare this function in this step, and we call it again in here. Okay, and finally this is the result. So this is how you have to write the function, and you have to call you have to use the function in the coding that we are going to do today for merge sort. Okay, for quick sort there will be same type of coding. By the way, anyone try to write the code for insertion sort in C? I think in the last class I have done the coding for selection sort and bubble sort. So any one of you have tried to do the insertion sort? It's almost same type of code will be applicable in that case. Okay, if you have not done it, then try. The insertion sort is more or less similar to I think both the selection sort and bubble sort. You just have to change the inner loop a little bit, the conditions, and everything will be. There are I think two inner loops going on in insertion sort. There will be one for outer for loop. The inner loop will be based on some conditions. So if you recall that insertion sort in the best case will give you like order in log n time. So okay. Fine. Let's start the coding. And I think function is somewhat clear. What is a function? How to write a function in C. So today we will do the coding for merge sort, and for that okay. So we'll use this function in anything else. I think it. Okay. Okay. Fine. So it to is my screen visible? Can you guys see my screen? Oh, okay, fine. Okay. Okay, so do you remember merge sort algorithm? Yes. So what do you do in merge sort? Can anyone tell me? What is the how merge sort performs? Roughly equal parts. Take left subarray and right subarray recursively. Yes. So we do the same thing in here. We will write in this code. We will divide first. We will divide. So for that, first we will write a function actually. But okay. So first we declare a function. Okay. So if you remember, there are two functions. One is merge sort, and another one is merge. Right? Merge sort is what? Merge sort is you corresponding to like you find the middle and divide it into two parts, and then you then sort both the subarrays recursively. Yeah. Then you divide it into two subarrays, and merge is the corresponding to when you merge the two subarrays. Okay. So first I will write the function corresponding to the void. Sorry, not the void. The merge. Okay. So for that, I use this function. So I declare it as void. I I don't know the type. I'm not specifying any type, so I'm using the void. Now I call the name of the function. Is I name as say, let's say merge, and then you need, what do you need in here? In the argument, now this part is the a type that will return. It will return. It's a void, so there is no specific type that will return. It will return no values corresponding to this function when it's called. It's and the name of the function is here. It's called merged. Merge. Now, if you remember, I have to declare the argument of that function, An argument contains the type of the variables inside type of the variable and the name of the variable. So first we need an array. In merge we are passing an array and also the left, right and mid value corresponding to it. Okay. So have another left, have integer right, and you have integer middle. Okay. So these are your argument for merging. Now this means, see, if you recall, we in previous classes we have defined array like a some third bracket n defining the size of array. This a empty third bracket also uh, defines an array having integer elements, but the size is not size in here is not fixed like what we have used previously. When we have used like an, then the size of array is bounded by size of array is n, but here the size we don't know. Okay, and for this, since it's taking some memory I don't know, I am using another header file. This is called standard library. Sorry. Okay. So okay, now I can define the function. So what is the step at merging? What do you do? We have a left array, we have a right array, and we need to merge these two, right? Okay. So yeah, the other header is C. I just told that you can see that this array here is not a specific size. Okay. Previously, when we define an array in array, we defined it like array and its size. Now the empty bracket means the size of this array is not uh, known actually. It stores integer type elements in it, but the number in the memory allocation, I don't know that how many slots it needs. Okay, so in that case, since it's this stdlib, it deals with this kind of things where the memory allocation is a little bit random, or you don't know that how many allocations are there. So standard library is corresponding to that header file. Standard library will handle this kind of things. So that's why I am using this second header file stdlib.h in here. Okay. So when there is like this is called a dynamic allocation. Okay. So when the memory, so when there is this kind of dynamic memory allocations, you can use this standard library header file. You use this standard library header file. We use this standard library header file to uh, handle those cases. This deals with those dynamic memory allocations. Okay. So you need to break your array into two parts, right? That would be your left array and that would be your right array. So if you want to break, like what should be the size of the right array or left array? So your middle element must belong to like at least one of these subarray. Okay, either it should be in the left or it should be on the right. Okay, so I am including it in the left subarray. Okay, so for that I wrote this one. So okay, we can use left L for left. L equal to 8 minus left plus and the size of right. So this corresponds to the size of the left subarray and this is corresponding to the size of the right subarray. Okay. So now you have the length of those two subarrays. Next I define those left and right subarray. So next I define integer the size of this array is L and sorry and right size of this array is R. Okay. Now you have left subarray, right subarray. Now you can go for your merging. Okay. So how do we do this? So okay. So we define these two subarray, left subarray, right subarray. Now you need to uh, put elements in this subarray. Okay. So what do we do? For I equal to 0, I L plus. So what I do? I assign this left I to be the element of left plus I. Is it okay? We are now just assigning these elements in here. Okay. Next for loop is Next, I have to write subarray. This should be okay. Plus adding one element. So is it okay up to now? So since now we have found our left array and right subarray. Next, we do what? Next we merge these two arrays, right? So I have already defined I. Let's initialize this. So for merge to left subarray and right subarray, what do we need to check? If there is an element in for loop, there will be semicolon. Is there comma in? Oh, no. Oh, it should be semicolon. Yeah. It's an error. It should be semicolon. So okay. So are you familiar with this uh, double AND operation? So this double AND. This is actually showing the AND operation that both these conditions should hold. Okay. And the meaning of AND operation, the usual AND operation that we have, that we know. So to left array. So if the ith element of left array What is the meaning of this step? And what is the meaning of this while loop? What are we doing in here? We have this left subarray, we have this right subarray that we obtain. Now we are merging. Okay. So if we have an element, so while you are merging these two arrays, what do you need to check? You need to check that it okay. So while you are merging two arrays, so what you are checking that if you take any element of the left subarray, if it is smaller than the right subarray, then you put that element in the left subarray corresponding to its correct position, and that's what is happening in here. Left subarray element is left subarray, then we are marching in array A. Yes, I mean we are doing that. We are the k is initialized as the left. That means the smallest value. Okay. So it's not complete yet. I mean, the while loop has another part, and there is actually an else condition after that. Okay, let me write it, then maybe it is clear. Else what we do, if it is not the smallest, then we assign this element to be the of the right array, and we increment j and k. Now I think it's clear to understand. So what is happening in here is that if your left subarray is smaller than the right subarray, then you put that in your kth element, starting with the smallest element. So you put your smallest element in the left side, and that's how you get a sorted array. Right? And you keep on incrementing k. Okay. And why this both and is needed? Because you want to compute compute both left subarray and right subarray. The total length is L, and it's actually L plus R. So you are covering all these left subarray elements. As well, after that, when you are finished, you will, if there is any right subarray left, then you also cover those elements. And as soon as soon as this left right subarray will be empty, then you can. I mean, as long as this right subarray or left subarray or whichever is longer has elements, this loop will go on and allocate the integer to its correct spot. Okay. So this loop is corresponding to that one. Okay. Now another to deal with the remaining elements. If there is anything left, then you just
copy it in here. Okay. And okay, so what is the AND operation? So this AND operation, so that's what I was talking about right now a while ago, that if you exhaust one of these, yeah, you will check the remaining elements. That's what I'm doing right now. I took the remaining elements and I put it in here, and I'll take another this corresponding to the left subarray, and if there is any right subarray left, then that would be dealt with in this next while loop. So we have this. Okay. So this is our void merge function. So now we call this thing, we write another function. This again a void function. This will do the merge sort. In the arguments, again I will pass an array, and same things you need. In the left you need a right, and you need the middle. Don't need the middle. Yeah, and determine the middle. So you find the middle. Teacher, middle. Left. Define. Okay. So now you find the middle. Now you call this smart sort function recursive. Meet, sorry. Should be meet. And again, call the merge sort in the remaining part. And after that you merge these two. So I think this is the order have defined. So this is doing the merge sort. It is calling the merge function now. Okay, now we are ready to write our function in here. So similarly, like previous, in the previous class, we can define integer n. Now we call the function merge sort directly. A starting with the 0th element, and the right index is n minus 1. Okay, and now we want the output. To 0. Plus I just want the output. This is how it goes. Let's run this one. Check if there is any error. Okay. Oh yes, I have not declared the array. Second mistake. So say 5. So there are some errors. Okay, let's check what is the error. This code. Not picking, not sort. First the value. 0, 1. So let me check if there is any wrong. Correct. So left, that's one right. Okay, correct. Zero minus one. Yes, it is correct. It's not. it can be very size predefined. Okay, let me try. Think anything wrong with the code? Okay, and let me define the array itself instead of defining. No. Scanf is to scan the input. The printf is going to show you uh, the corresponding array, like whatever is the variable that you're calling. Okay. Printf %d will show you that variable value of that variable. But scanf will like scan the input and check whether it's correct or not. It will read it. It will read it like an integer, whether you are defining an integer and you're giving value is integer or not. It will read. So scanf is only for input purposes. It's not for output purposes. In the last for loop, I wanted to print the array, the sorted array. It's not depending on that. I think it's related to this memory allocation. Let me just define the array itself. Okay, I define the array and I calculate its this n. This is the size of is basically calculates the length of the array. Okay, I will discuss the how the size of is defined. Just let me check whether it's giving the correct answer or not. No. AN is not needed. If we are defining the array itself in there, then the size, mentioning the size is not that much important. We can calculate the size. That's what we have done in here. We've calculated the size, but somehow it's not about AN. No, it's taking input, but the output is not generated. It's also taking input. It's not a problem. The problem is generating the output. So I think there is some issue with the memory allocation. Let me check. directly. Then so meet left plus is okay. Should be equal. No, mark sort function. It doesn't have any condition in there. Is it left greater than right happening in here? Oh, okay, left greater than right condition. Okay, right. Yeah. It can happen. stopping now. Text. Text machine detected. Okay. Now the point was that actually it was happening in there. I thought that I actually forgot about writing this if loop. The case when left is greater than right. The recursion was not stopping in that case. Yes. That was the reason. Yeah. So now it's running. And I guess it will run in the previous format also. Without this. Yeah, it's working now. So similarly, you can try quick sort. Okay. Try quick sort algorithm. But for quick sort, I think, okay, let me paste this one. I think some. No, someone has already done this code, I think. That's in. Is correct. Okay. Okay. So the error was in the algorithm, not in the code. Okay. Fine. Uh, Now for quick sort, what is the quick sort algorithm? If you do you remember what is quick sort? So okay. So given a pivot, right? Here, of course, you we choose a element as a pivot, right? And we partition based on that. So now there are like it's depending on how we choose the pivot. We can yeah, a first element is proceed merge sort. Yes. Instead of this mid element in here, you will have this pivot. Okay. So, but the question is how to choose the pivot. Hmm. So, if you see in the tutorial, we have already seen that it's the pivot for which the element is like for which based on which the partition is depending, and also it's not that we pivot and follow the merge sort. Are we doing the merge sort after finding pivot? What do you do after finding pivot? So all the elements that are less than the pivot should be on the left. Yes, sort left. I mean, the pivot after finding pivot, what does it do? it partitions based on the pivot. The elements that are on the left of the pivot, sorry, the elements that are smaller than the pivot should be on the left subarray, and the elements that are bigger, that would be on the right subarray, right? So what we are doing in here, in this first function, we were what we are doing, we were selecting left, right, and mid, and we uh, have the left subarray, right subarray, and we assign based on which one is bigger or not. Okay. Yes, left subarray is smaller than pivot. Yes. So that's what we have to do. First, create the left and right subarray, and then we apply the quick sort recursively on these two subarrays. Okay. So can you guys try to write this one? Like choose any element as pivot, or rather, you know how to run a for loop now. Okay. So do you, can you come up with a code that can find the maximum element in one go, or minimum element? I mean, you can take the maximum element or minimum element as pivot. So let's say you can process it in the beginning actually. So in one pass of the algorithm, can you detect a maximum and or minimum element of an array, of a given array? So if an array is given, okay, you what do is you check. You start with the first element, and you check whether there is a element that is bigger than that, and you put that element in the maximum. If there is any other element which is bigger than that, you shift your maximum to that value. Okay. So if you proceed in this way, if you traverse the whole array in this way, then you will find the maximum element, and similarly you will find the minimum element. So once you find the maximum minimum element, you discard those two positions and select any other element in the array as a pivot. Okay. So am I clear, or like what I'm saying is that you should yeah, you are saying that first element as pivot, but it might be that the first element could be the maximum or minimum element. So that would be a bad partition. First element, choosing the first element is a bad partition actually. May result in a bad partition. So what I am suggesting is that actually the better way is to find the median, but uh, what you can do is that you can, by one pass, you can determine the maximum and minimum element, and you discard that these two are not my pivots. I'm choosing any other index as a pivot. Okay. So you can try that one. So try to write this one. I'll pick. Okay, if it is since difficult, you can start with the first element as pivot. You can write that code. Okay, so it's actually done. Okay, so what do you do in here? We need to partition, right? So instead of March, so instead of March, now we need to find the position where we are partitioning, and what should be the index of the partition, and what should be the remaining subarrays. Okay, so now see, you need to find the index of the partition. So instead of void, I'm using integer. And this to be partition. Okay, the array is same, and you have the left. You can say left, right, but you don't need the middle. Okay. Now you need a pivot. So ij, let's say p. So one time I so okay. say E is our this first element. So it's left. And I is the index of that left. And J is the right index. We have array, have take the first position. We know the index of that one as well as the highest index. Now we are partitioning this one. The same, to not repeat the same mistake, I am considering that this should be always less than. The lower index should be always lower than the higher. Now we have to separate like the elements which are smaller than pivot and which are higher than pivot. So while so we need to find the index of our like partition. So what this while loop is doing is that we are so what we are doing is that we are increasing this index till we find an element which is greater than the pivot. Okay. So that will be the index of the pivot. That after that you will find a element which is greater than pivot. So you can partition in that in that index. Okay. So similarly, we also proceed in the opposite direction. That we find the first element which is smaller than the pivot, which is yeah, smaller than the pivot. So we traverse from this position. We keep on decreasing. Okay. So now, what if So you we are keep on increasing this I, and we find the first element, which is the index of the first element is bigger than p, the pivot, and the index smaller. If it's greater, then we just simply swap AI and AJ. Swap. So then finally we again swap with our index and the index of J, and the J will be the index corresponding to the partition, and our function will return that out. Left and right. This is something. So we determine this Oh, okay. So it's working. Okay. Now see, it's a very simple modification. Uh, just you have to change this function. So this function actually returning the position in which you have to partition. Okay, so this basically determines the location of P. Okay, now what we are doing is that we have a left index and a right index. So obviously the right index should be greater than the left index. So that's why we are keep running this while loop till our left index is smaller than the right index. Okay. Now what we do is that we check the we run again another while loop. We are checking whether there is an element which is smaller, which has like which is smaller than our pivot. Okay, so we started with the leftmost element, I mean the first element as pivot. So we select that element, first element, and we are checking whether uh, there is an element which is smaller than the pivot from the left, starting with the first position. So we keep on increasing. So this while loop will go on till we find a element which is greater than the pivot. So there is an index of I at that point. So what does it implies? So these will be the elements that are smaller than P. Okay, from the left. These are the consecutive elements. Okay. Now this should be on the left of P. Now also we why do we need to move another way? Like there could be like elements which are smaller than P from the remaining part, because your array could be looking like let's say if you take this example, even this example, is it evident? I don't know. Yeah. So if you look at this example, the first element is 12. 3 is smaller than 12. 5, everything is smaller actually, so it will not work in here. Okay. Okay, if you look at this subarray, let's say there is a bigger, but yeah, think about from 5. So 5, 7, 4. So the first element, if you run this while loop, the while loop in here, it will first run 5, then it will stop at 7 because it's bigger than the pivot 5. Then it will, then our I will stop at that index. But there is an element which is smaller than 5 in the remaining part. So that's why we are running from the backwards also. We are determining the elements in this while loop. Again, we are determining the elements that are smaller, that are bigger than the pivot. Okay, so we keep on decreasing that index. Now, if you have a smaller index, that means you have stopped somewhere before your bigger, like the first smallest element from the left side occurs. Then you know that you have to swap these two elements, because this is the smallest element from the left, this is the biggest element from the right. So these two are not in the correct position. So you have to swap them. So that's what we are doing. Whenever we are having this situation, we swap. Okay. So now this will continue. This while loop will go on. Okay. And until I less than j. So after this execution of while loop, you will have uh, your left element, the leftmost element in one side, and you have your uh, index j or I, whatever, that would be equal. Like when this while loop will execute, will be stopped, then I and j would be on the same index. So your that would be the position of your uh, first element, that is the pivot. Okay, so you swap with the jth element and the first element, that's the leftmost element. That's what we have done in here. So that's why we are swapping, and we return the index j. So that's the index of partitioning. Now we use that same thing in this part. We just call it the partition function, and we call recursively quicksort on the rest of the portions. And that's how get this. If you follow the algorithm, it's not that much difficult. I think you can take. I'm sharing this. So okay. Uh, these are the two codes, and okay, so we have already done these two problems and the corresponding codes, but you can try to like improve the pivot, like how we are choosing the pivot. We are choosing the, yes, I will I will upload after the class. I will upload the PDF. Uh, so what we are doing, so let's focus on this code actually, the pivot. And everything that you see that in the tutorial also you have seen that it's basically depending on how you choose the pivot. So here we just define p equal to left of this, uh, and see your, like every time you partition your pivot would be based on that choice, but it's actually uh, it's kind of counterintuitive. But if you choose your pivot randomly, like not the first number, any number, okay, instead of this p equal to left, you can like take any index. Okay, you don't specify the index, but in this code you have to. But if you randomly pick the pivot, then it actually runs in a better time. So that's another modification of quicksort. That's called randomized quicksort. I think it will be covered in the next class. Uh, so that will result in this order n log n running time, almost like in most of the cases. It's a kind of probabilistic. Uh, the running time is actually probabilistic, but it's actually most of the time it will give the summary is that it most of the time it will give you order n log n running time. Okay, so one thing uh, one thing is that you can also try to implement this merge sort into uh, merge sort, yeah, merge sort algorithm, or quick sort, even quick sort, by partitioning into like 1 is to 2, 1 is to 3, or this kind of factors. You can try and you can check. You just have to play with the indexes, that how we find the middle, how we find the uh, pivot. You just have to play with those indexes. So you have to play with those indices only, and you can find the corresponding like algorithm for that. So I would like you guys to try the other partitioning, like 1 is to 2 partitioning, or like uh, the 1 is to 3. I think we have done in this class. So these kind of partitioning into these problems, into this code, and try to see uh, the changes that you can. Okay, so you don't have to remember these codes. If you are remembering, then it's a problem. It's you have to like see. You have to remember the algorithm actually, not remember. I mean, you have to think about the algorithm. Everything is coming from the algorithm. All these problems are basically it's this code is an implementation of the algorithm. Okay, so you don't need to remember the code. Basically, what you have to do is that you have to follow the scene, understand the algorithm. Yeah, that's the thing. You have to understand the algorithm and follow the like syntax and all the what I can say, format of the code. Like whatever platform you are using, if you are someone has written the code in Python, so whatever language you are using, just follow that language correctly and instructions of the language correctly and follow the algorithm. You have to mainly think about the algorithm, because in this code there is nothing. We these are the long, these are looking like very long codes or something, but what we are actually doing, we are partitioning this simple array into two parts and we are just running the recurrence. So basically there is nothing, but to implement that one we need to, like for C it's a kind of a little bit longer implementation, although I can do swap using functions using pointers, but I did not. uh, this can be done, like the swaps can be done in simpler way using functions, using, yeah, C++ is very similar. Yes, C++ and C are almost similar, but also C++ is more, like more advanced, so you can like perform some tasks very easily. In C you have to write in a little bit more details, um, especially when you are not familiar with C. If you are not familiar with C, so right. Yeah, upgraded version. Yeah, C++ is invented after C. C++ is it's a very very important language also. If you those who are studying Python, I mean Python or other coding languages, I don't know, maybe R or C++. No, not C. You can go for C++. I don't recommend that you should learn C. C is the base language. If you are like very good in C, then I think you can capture the other languages like C++ very easily. But C++ is a very important language. See, Pythons are mostly, uh, if you see, like these days developers are using Pythons and all. But C++ is widely used in. I have heard that some people working in companies like I met one guy from Qualcomm. He was using C++. Their company is using C++. So if you are like working in those platforms, those companies, you might need C++. Okay. So I would suggest that if you are not interested in C, that's fine. C is kind of a little bit boring language, I know, but at least go for C++. No, Python, C. You have already done in Python, right? C is the fastest language. I think yes, C is fast. C is the basic language actually. If you if you if you think that fastest, I won't say that fastest. There is no fast or slow language. C is basic language. C++ is very powerful actually. Yes. Assembly is the assembly is the so you are going deeper. No, but I think that C is the most basic language, and if you have efficiency in C, if you know C, you can capture the other languages easily. Assembly language is just you are now you will go to like a computer hardware. Yeah, you are saying the right thing. Computer hardware. Mother language. So you you guys, I think that's why it's important to understand C. SQL is different. SQL is for uh, like data management, that you can learn in different class. Okay. Um, C hash and C++. I have not done C sharp, I mean C hash, so I don't know about that. I mostly have done in C, C++. SQL is a different course. SQL is not covered in the algorithm. I mean, this is a class of algorithm and uh, data structure. So now there is nothing like best. There is nothing like best. Every language has its own benefits. Some are very user friendly, some are very basic languages. So, but it is good to be efficient in at least one of them. If you are efficient in one of them, very efficient, then you have advantage. Uh, okay, fine. So what I was saying is that you guys try to implement those problems, those variations of merge sort and quick sort in this uh, in this codes that we have discussed. Then you will have some idea about how it works. It's for data management. Yeah, data management. It's a different thing. Python is like no. C is more close to that. Python in Python you will miss a lot of things. In C you will see that in the next we will have this thing called pointers. I am going to use it maybe from the next class. So if we have pointers, if we have uh, in C we don't have in Python you don't have this concept of pointer, na? So that would be a different thing. I think it should be uh, in C. Whenever you are studying an algorithm or data structure courses, it should be in C. Because then you will learn the basics. Okay, fine. Then that's it for today. Yeah, data DBMS is different thing. It's not in here. It's a data. It's not data. It's a design and analysis of algorithm, I guess. So analysis of algorithm is different. Database is different. Okay. So I'm stopping. I paste this code, right? I've already shared this code, I think. This sort is already shared. So. Okay, thank you everyone. I'm ending the meeting.